Title of the first section is Finding Determinants of a 2 by 2 matrix. In this section, we'll find the determinant of a 2 by 2 matrix. The definition is a matrix which will have two vertical lines on the outside. And a 2 by 2 matrix means we'll have 2 rows and 2 columns. We'll put A for the first number, B for the second number in the first row. C will be on the second row, and D will be the second number in the second row. A matrix is a set of numbers. To find the determinant of this matrix, it is similar to cross multiplying. We will multiply the top left number A times the bottom right number D, and from that we'll subtract the bottom left number C, and the top number B will multiply. So the definition of a determinant would be A times D minus C times B. First problem we'll solve will be the matrix, 2 by 2 matrix. The numbers are -2, 5, 6, and 8. Again, to find the determinant of this matrix, you can draw the x inside the matrix, and we'll have -2 times 8, which would be -16. And we'll subtract from that 6 times 5, which would be 30. -16 minus 30 will be -46, which would be the determinant of this matrix. Title of the next section is Determinants of a 3 by 3 matrix. In this section, we'll find the determinant of a 3 by 3 matrix. The definition or formula for this section, the matrix that we'll have 3 numbers across, A, B, and C. The second row will be D, E, and F. And the last row will be G, H, and I. So the 3 by 3 matrix will have 3 columns and 3 rows. To find the determinant of a 3 by 3 matrix, what we'll do is take the first column, which is A, D, and G, and we'll rewrite that outside the matrix. And we'll also take the second column, which is B, E, and H, and write that next to it also on the outside of the matrix. To solve the determinant from here, we'll look at the diagonals of the matrix. The first diagonal will be A, E, and I. Taking the 3 numbers in the first diagonal, we'll multiply those, A times E times I. Taking the second diagonal of the matrix, which is B, F, and G, we'll again multiply those. To get B, F, and G, we'll add to it, which would be B, F, G. And the third diagonal, going from top left to bottom right, would be C, D, and H. Again, multiplying all 3 numbers, we'll add that to the total, C, D, and H. For the second part of the determinant, we'll continue to do that diagonals, but we'll go from the bottom left up to the top right. So this time we'll have G, E, and C. We'll multiply those 3 numbers together. The differences we'll subtract. G, E, and C. Continuing the next diagonal, H, F, and A. Again, we'll multiply all three of those numbers, H times F times A, but again, this time we'll subtract since it's the diagonal going from the bottom left to the top right. And the last diagonal that we have, I, D, and B. Again, we'll multiply those and subtract them, which will be I, D, and B. So the determinant of a 3 by 3 matrix will be the three diagonals going from the top left to the bottom right, adding those together. And we'll also take the three diagonals going from bottom left to top right, and we'll subtract those from the total. After all this computation, the single number will be the determinant of the 3 by 3 matrix. First problem for the section. Draw the 3 by 3 matrix. The first row will have -1, 3, and -3. The second row will have 4, -2, and -1. And the last row will have 0, -5, and 2. To find the determinant again, we'll take the first column, -1, 4, and 0, and copy that outside the matrix. And also the second column, 3, -2, -5, we'll copy that outside the matrix. Once we have that done, we can go through and circle our diagonals, multiply the numbers, and find the determinant. The first diagonal, -1, -2, and +2. -1 times -2 would be +2, times 2 more would be 4. So the first number we'll use in the computation will be 4. The second diagonal, 3 times -1 times 0. Anytime you have 0 in a diagonal, we'll be adding the number 0. And the third diagonal, -3, 4, -5. -3 times 4 would be -12. -12 times -5 would be +60. The second part of the question, we'll start at the bottom left, go into the top right. We'll have 0, -2, and -3. Multiplying those numbers, since we have 1 0, it'll be 0, and we'll be subtracting the diagonals that go upwards. The next diagonal, -5, -1, and -1. -5 times -1 would be 5, times -1 would be -5, so we'll be subtracting -5. And the last diagonal, 2, 4, and 3. 2 times 4 would be 8, times 3 would be 24, and we'll be subtracting 24. If we add the top numbers together, 4 plus 60 will give us 64. The second row that we did, the minus would change to a +5. We'll have 5 minus 24, which is -19. Combining those two numbers, we'll end up with our answer of 45, which will be the determinant of this 3 by 3 matrix. For Cramer's rule, you can solve systems of equations using matrices and the determinants. The solution to equations, if you have two standard form equations, where x and y again are the same side, equaling a number, the solutions would be x equals. We'll do a 2 by 2 determinant, but we'll take the numbers on the right hand side and the coefficients of y will be the numerator top part for the determinant. We'll make a fraction out of that, and we'll divide by the determinant made from the x's and the y's. Likewise, the solution for y would equal, we'll take a and c, which are the coefficients in front of x, and we'll use the numbers that the equation is equal to complete the determinant, and divided by the same determinant as x was, a, b, c, and d, which are the coefficients of x and y. Solving these determinants and dividing them out, you can find the solutions of x equals and y equals. One special case is a, b, c, d. The determinant cannot equal 0, otherwise your denominator would be 0 and your solution would be undefined. Problem for this section is 5x plus 7y equals 13. And second equation, 2x minus 5y equals 13. And again, instead of using substitution or elimination, you could use Cramer's rule by finding the matrices and determinants and solving for x and y. For example, x equals, we'll have the first determinant, which would be 13 and 13, the two numbers that are equal in the equations. And we'll also take the y coefficients, which are 7 and negative 5. Divided by the matrix for the denominator is the same as the x and y coefficients, which would be 5 and 2, and 7 and negative 5. Setting up the solution for y would equal the first matrix, which would be the x coefficients, 5 and 2, and then the two numbers is equal to 13 and 13. For the denominator, it would be the same as the x, which again are the coefficients of x and y, which would be 5 and 2, and 7 and negative 5. Solving from here, for x we can use the determinant, where again you multiply the top left times the bottom right, 13 times negative 5, which would be negative 65. And we'll subtract from that 13 times 7, which would be 91. Divided by, we'll do the top left 5 times the bottom right negative 5, which would be negative 25, minus 2 times 7, which is 14. Simplifying this, negative 65 minus 91 would be negative 156, divided by negative 25 minus 14, it's negative 39, and that would be equal to 4. So x in this case would equal 4. Solving y, the numerator, we find the determinant would be 5 times 13, which would be 65, minus 2 times 13, which is 26, divided by the determinant of the y is the same as the denominator for the x, which would be negative 25 minus 14. 5 times negative 5, and 2 times 7. Solving for the y, 65 minus 26 will be 39, divided by negative 25 minus 14 would be negative 39, dividing out would be negative 1. So x would equal 4, y would equal negative 1, or the two lines would be equal, or they cross at the point 4, comma, negative 1. And that would be the solution for the systems of equations.